In this video, we're going to use truth table to prove that two statements, compound statements involving conditional statements to be logically equivalent. So we have the first compound statement, P or Q implies R. And the second compound statement is P implies R and Q implies R. And we want to prove that they are logically equivalent. So now let's first fill in the truth values for P, Q, R. So if we take a look at the left-hand side, right-hand side, we have three simple statements, which are P, Q, R. And again, we have those 8 different combinations of their truth values. So let's put them in here. TTT, TTF, TFT, TFF. Now let's change the truth value of P. F, T, T, F, T, F, 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 T, F, F, F. Okay, now first we're gonna work on the left-hand side. We will do P or Q, the condition. So we look at the first two columns, and for OR statement, if one of them is true, then it's true. So we have T, 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 F, F. And now we would do the implication. In the textbook, they actually did these two first, and they put the last step on each side in the last two columns, so they can compare side by side. But you can do that way. But I would prefer to finish the left-hand side first. So I'm going to do this implication on the left-hand side. Okay, so in this case, we're looking at the condition column. This is the, or you can call it hypothesis. This is the hypothesis column. And then the consequence column or conclusion. So be a little bit careful, so because they're not the normal way, it's a little switch, these two columns. So first, recall that for a conditional statement, if first look at the condition. So I'm going to take a look at the condition. Notice that the first 6 cases, they all have the true. See, look at here, have true values. Let me use a different color. So that means the truth value for this implication is going to be the same as the consequence. So I just have to copy those consequences there. So look at these and copy them and put in here. So we get T, F, T, F, T, F. Now for the last two, because their hypotheses are false, so it doesn't matter if the conclusion is true or false. This conditional statement, or you can call it implication, is always going to be true. Okay, now next we're gonna, this is the left-hand side, let me mark it. And the right-hand side, we're gonna do the parentheses first. P implies R. So we look at the first and the third column. So let's not worry about these two anymore. And so P is the hypothesis, and because the first 4 are true, so that means that this implication conditional statement will have the same truth value as R. So we're going to copy those values of R here. T, F, T, F. Now for the next 4 cases, because the condition or the hypothesis is false, so we're going to put true for this conditional statement. Okay, now let's do the second one. If Q, then R. So this time Q is the hypothesis. So let's look at Q. These two are true. These two are also true. So we're going to copy the values for the values for R, because if the hypothesis is true, then the truth value of this conditional statement would be the same as the conclusion R. So that will give us TF, and this one will be TF. For the rest of them, because the hypotheses are false, so we're gonna just put true for all of the others. So let me. Will be false, false. I'm sorry, put true, 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 true. Okay, so next we can do the last step on the right hand side. P implying R and Q implying R. So this time we look at these 2 columns, and notice that the first side is a conjunction. So we look at these 2 columns here. Conjunction, both of them have to be true in order to get true. So true, false, true, false, true, false, true, true. And now we need to compare the left-hand side column and the right-hand side column so we can prove they do match. So we have on the left-hand side we have TF, 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 TT, and on the right-hand side we got the same thing, TF, 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 TT. Okay, so they all match. So now we proved that they are logically equivalent.